What's up guys? Today I'm going to do Google Kickstart Round E and see if I have what it takes to become a software engineer at Google. The round is starting in 4 seconds. 4 problems, this is going to be intense. And usually the problems load very slowly. You might need to skip forward by 30 seconds or something like that. Okay, finally. They're loading. Am I going to start with problem B first? Or problem A? Okay, find the difference array and then find the maximum equal subarray. It's equal to a of I minus a of I plus 1. Answer starts at 1. And while j plus 1, try to extend the current subarray. Maximum of j minus I plus 1. This is the length. You update it, and B array is only why did my program stop? J should be equal to I at first. Three, 2, and 5. So is it okay? It's plus 2 then. Okay, second problem. Okay, this got AC. The next problem is a constructive problem. So I'm going to look at C, and I'm going to put C occurrences of n. First thing I'm going to check is that if C plus A minus C plus B minus C is greater than n, then it's impossible to fit them in n buildings. Otherwise, n can be 1. So what I'm going to do is I'll put n minus 1 here. I don't see an easy construction for this. Where we put n minus 1, a minus c occurrences here, and then b minus c occurrences here. And then the rest should be n minus 2. The rest will just be n minus 2 somewhere over here. Okay, that makes sense. For a minus c, write n minus 1. N minus whatever this expression is. We'll put a building with n minus 2. Then put a building with n. Then we'll put b minus c buildings here with n minus 1. And then this should satisfy the given conditions. 2, 3, 4, 4. Wait, this is placed over here, which is not supposed to happen. Okay, instead, a is greater than c, and we can place this here. However, if a is equal to c, then we have to place that over there. So 3 over here, impossible, and then 3, 3, and then 2, okay. Let's hope there's some edge case that I didn't miss. Oh, wrong answer, shoot. Okay, it might be because I print out n minus 2 somewhere. And I was not supposed to print out n minus 2. That happens when n is equal to 2. So there's an edge case when n is equal to 2. Equal to, and everything is equal to 1. Oh, no, there's an edge case when a is equal to b, and b is equal to c. A is equal to c, and b is equal to c. But c is only equal to 1. Okay, so c is greater than 1, then we can place this here. C is greater than 1, and this is satisfied. Then we place it over here. Otherwise, we go down there. Oh shoot, still wrong answer. Okay, which case am I missing? When n is equal to 1. Okay, it's probably when n is equal to 1, then it still works. So the condition is that r of I has to be greater than or equal to this condition has to be satisfied for the ones that we choose. Okay, finally got accepted, but that's still a lot of penalty. Okay, so this condition has to be satisfied. So in other words, we find the smallest value of this. It means that among the ones we chose. Okay, so let's sort all the toys by this, and then iterate over the minimum toy. And let's see how many we can take using 2 pointers. Or binary search. As we increase the minimum, yeah, we can take more. So it's 2 pointers. So we'll sort all the toys by the sum of R and E. Answer starts at 0, and then play world as long as possible. If we play as long as possible, then that's basically just the sum of everything. Print number and in definitely. I can't spell at all. Okay, and then otherwise you calculate the sum. You move 0 and then, yeah, the sum is this. Okay, now we calculate the answer with 2 pointers. So if the minimum is this, let's try adding j. So if j is less than n and sum plus the e-value of j still less than or equal to the current one. Wait, is it greater or smaller? Okay, never mind, smaller then. Then I'm looking for the max. Which means I got a lot of things wrong here. But it shouldn't be that hard to fix. We find how many we need. Wait, does that mean the bigger the better? That means we try to take everything, so, or at least the suffix. Okay, so sum starts at 0. And then we test this. Phi of I of 0 plus phi of I of 1 is less than or equal to sum. Then great, that means we found the answer and we can't quit. Otherwise, you have to remove the current one from the sum. Having trouble copying the test case. Last one is weird. Oh, okay, so actually, it's more than just the sum. So it's the sum plus the first time. The sum plus the first time something, first time he remembers the toy. So the first e plus r greater than or equal to the sum of all the other e values. Maybe we actually use this again. Can we reorder the toys however you want? That might mean that we need the original order of everything. How do we keep the index and then we keep removing the maximum? I think that might actually work. Wait, I have no idea what I'm doing. This is... Wait, I'm probably missing something here. One, two, three, 1, 2. And then... Sometimes... Okay, which ones do I remove then? Obviously remove the first one which doesn't work and then see what happens. So I probably put everything into a priority queue. I need to extract the smallest index of the toy which doesn't work. Which means I might need a binary index tree to store the sum of everything. To store the sum of the toys that I haven't removed so far. don't know if I'm overcomplicating this, but whatever. Which means I need to make some of my variables global, which I don't like. I also need the current sum. Actually, I don't need to maintain the sum. I just need to update it in the binary index tree. Answer starts at 0. Actually, the answer is a pair of integers. Starts with the sum of everything, and we remove nothing. And while there's something in our priority queue, we take the index keep track of how many we removed. Max the answer with current sum of everything plus the current sum before the index. You also need everything, all the indices sorted by their sum. Push back sum and the index. And after that, the sum is greater than the current sum of everything. We'll remove it. And we update this in the binary index tree. Well, then we perform this operation again to update the priority queue with potential toys, which we need to remove. The pretests aren't very strong. But anyways, let's move on. Yeah, 3 is actually kind of hard. Okay, so you're given a graph. Wrong answer. Do I have integer overflow or something? It might just be a typo. Let me check my code. Wait, everything was sorted already. Okay, it's supposed to be up there. Stone can carry no more than 1 stone at a time. What are constraints? 300. M is somewhat small. What's S? Stone types and recipes. Interesting. K is less than or equal to 3. Okay, cool. Got correct now. Why 3 though? Always numbered 1. What's C again? Oh, number of stone types. Lost G costs 1 unit of energy. This entire graph connected. It's possible to get, okay. Then they have to be at the same junction, right? I'm thinking is dp of, this might not be dp and actually just extra, but whatever. dpu S means time to get stone S at U. Is it, well, I don't think the answer will actually be that large. So some of these start at 0. Now whenever a recipe is created, so basically whenever this is updated, this will be updated like (300) times. We will go through all of our recipes and then check if each recipe works, and if it does work, then we can produce a stone. This seems doable. So our state is a pair of integers. Okay. So NMSR. And then why is this 5? Okay, that doesn't really matter. Might as well put this here. There's the adjacency list, which I need to reset each time. And then there are the rows. Okay, the rows will be placed in the adjacency list. Then the next n lines are the stones, the initial stone types. C is the number of available. Distance from IDJ, node I, stone J will be set to 0 at first. And we need to reset the distance in the beginning as well. And then we have a priority queue. And let me just make sure this is nested correctly. Yeah, okay, it seems to be good. And we add this thing into 0 and then the coordinates. This is compile. Okay, I actually have to name the type. The last R lines are the recipes. And then first, we read in K. Just read the entire thing. Oh, also, I need to use change from 1 indexing to 0 indexing. Okay, all the recipes are there. Answer starts at can answer be that big? Greater than or equal to this? Maybe it actually could. Whatever. The answer we just loop through. Distance to get 0 from any node. Okay, and then we have our main Dijkstra logic. P dot first is greater than the distance. Then we just continue. Okay, otherwise, first we go through adjacent edges. If d of u of 0, if current distance plus 1 is less than the distance to v, then we'll add this into the priority queue. And yeah. Okay, we also have, if we choose to use a recipe, for everything in R, just updated this, so if R find all of R of I, and we're finding this, the current stone. It's not equal to. Oh yeah, I also need to offset B as well. If it's equal, then this doesn't really matter, we can continue. Otherwise, new distance is the minimum of everything combined and infinity. dp of new distance starts at 0. And for everything inside the A of the recipe, we add that stone, the distance for that stone. And if this new distance is less than our B of I, then we do the same update. Okay, pretty much everything is finished, but there could still be a few bugs and things like that. 0, 0, 0. Okay, something did not work. Oh, S is set to this, okay. D20, it seems to work, hopefully. It actually does work. I already have enough penalty from all the other problems, so I don't want any more penalty. I have like 2 penalties for second and then 1 penalty for the third problem. Okay, I'm finally done, I think. Yeah, okay. So depending on, because I have 3 penalties, depending on other people, I think I'll probably remain second looking at the scoreboard. But depending on, because other people with smaller penalty might solve and overcome me. So overall, B, C, and D were much harder, and they were also much trickier to. They were also trickier cases, so it was really easy to get penalty because of this. Anyways, I'll wait for a bit and see what happens later. I'll just pause right now. So some time has passed, and it's confirmed that I'm second place. I only got second place, and I don't know if that's enough, if I have enough to work at Google. But hopefully they'll understand.